More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hello everyone, welcome back to Mathnasium Schoolhouse. Hopefully you're joining me here today because you joined us yesterday for Solving Proportions Part 1. So we're going to continue where we left off yesterday. I'll do a really quick review of what we saw yesterday and then continue with a new technique in solving proportions today. So I hope you guys are just as excited as I am. As always, there is a worksheet to follow along with. So I'm sure that will be reshared with you in just a second as well. You can pull that up if you're more comfortable following along using that alongside this video. Or you can pull it up later on and try those problems out on your own to see what you learned from today's lesson. If you find yourself struggling during today's lesson, your best bet is to reach out to nearest Mathnasium and we will create for you a customized, individualized learning plan specifically for you, where we'll make sure that you have all of those skills needed to really tackle proportions, which is, as you would have seen in the description, probably most appropriate for those of you going into middle school, just because you probably would have worked through a lot of these concepts that build towards the ability to solve proportions. But if you're in a lower grade or higher grade, you're more than welcome to join us. Absolutely. You might be super interested in these higher level math topics, or you need more practice, which is perfectly fine. We're all in different areas in our math journeys, and there's no problem in all of us being here today. So I welcome you all to help me with the math problems that we'll do together on my whiteboard in just 2 seconds by commenting. Looks like my comments aren't being too nice to me again today, so I'll be refreshing and checking up on your answers to make sure we're all on the same page here. So let's get started. Let's not waste any time here. I've just written down on my whiteboard in advance, just of course, the title of this part 2 of our Solving Proportions series. So we're looking at more proportions today. Yesterday, which will continue where we left off from yesterday, we looked at solving proportions using one specific technique, which builds off of our ability to create and write equivalent fractions. And within that, we found one useful technique was to reduce fractions that we had in our proportions, because we could see relationships between the numerators or the denominators a lot better. So let's review that with some of those remaining word problems that we had. So I'm going to share the PDF from yesterday, just some of those remaining questions, and then carry on to today's, where we'll look at a second technique. And maybe I'll just quickly write that here. This second technique is going to look at, this might be new to you or not. If you know what cross products is about, I'm interested to hear that, to read it. So go ahead and share that in the comments if you'd like. We'll look at this second technique, and typically the way that I like to do it, at least when I was a younger student, especially when I encountered proportions, I really liked to start off by seeing if I could use my knowledge of equivalent fractions and reducing fractions to solve them. But of course, numbers, fractions, math isn't always that nice to us. And so we need another technique to solve certain things, in this case proportions. And so there is another technique we can use for those other proportions. And so we'll see that today. All right, I'm going to share with you question number 15 from yesterday's worksheet. Let's carry on from there. If you guys tried it out on your own, wonderful. You can double check your answers with me, supposing that I did my math correctly. So let's see what we do here for number 15. I'll read it out loud. 85 cups of birdseed are needed to feed 20 birds. Great. We have that piece of information. Exactly how many cups of birdseed are needed to feed then 32 birds? And you guys shared with me yesterday a few other techniques. We can maybe find out how many cups of birdseed would be needed for one bird, and then multiply that to find 32 birds, which is another technique. But let's stick with what we worked with yesterday. So I'm just going to rewrite that word problem into a proportion here. And the way we talked about that yesterday was just to be consistent with our units. And so using that first piece of information, 85 cups, I'm just going to have that be in the numerator of my first fraction. All right. Then I'm comparing that provides for me enough birdseed for 20 birds. And so what I'm being asked for is how many cups of birdseed. So I really don't know. That's what I'm going to try to find. That's my unknown for now. Are needed to feed 32 birds. So that is what I took from that word problem. Now I'm left with a proportion. Yesterday we also decided that, you know what, there's still too many words there. The math isn't too clear. So what we could do is remove those units for the time being and rewrite our proportion this way. We could bring in a variable, maybe a capital C there. And we decided we would solve the proportions using equivalent fractions. Before that, we might decide to reduce this fraction here. And let me just refresh my comments here to see if you guys are helping me out on this one. And maybe you can tell me what you got for the cups here. Give you a few seconds to share that with me and for my comments to pop up. Where's the worksheet for today? Some of you are asking. It should be shared with you through one of my lovely helpers. So I will allow them to get this for you. Okay. If you're not able to follow along, it might be the case where you didn't tune in yesterday. This is a part 2 of a 2-day series, a 2-lesson series. So I might recommend that you pause the video here, take a look at yesterday's video, and then carry on with this session. All right? Perfect. So I'm not seeing the answer maybe just yet, but yeah, I'm not seeing it just yet. Maybe that's because my comments aren't refreshing. But in any case, we could reduce the 85 20ths here. Both of them are divisible by 5. We could start there. And once we reduce that, we could compare our new fraction and maybe specifically our new denominator with the 32. And that's what we looked at yesterday. And if you did that, maybe I'll use another color here, you should get C is equal to 136. Right? There we go. That was number 15. Let me just scroll down here. We can look at the last few questions on this worksheet from yesterday. So if I look at number 16, it reads, if Maggie can read 18 words in 8 seconds, exactly how many seconds would it take her to read 63 words? So let's see that. Again, I'm just going to take that information and I could maybe jump straight to my proportion without the units just yet. So let's do this one a different way. So we have 18 words in 8 seconds. Great. How many seconds? So it looks like I'm looking for this second denominator for 63 words. Okay. So I could do that and possibly look at reducing this first fraction, maybe by 2. So I can take 18 and divide it by 2, and that'll give me 9. 8 divided by 2 would give me 4. Why is that helpful to me? Hopefully it's apparent. Maybe instead of a question mark, let's bring in a variable. I'm looking for seconds, so I can have an S here possibly. And why is that helpful to me? Well, I know that 9 has a beautiful relationship with 63. What is that relationship? It would be that 9 multiplied by 7 gives me that 63. Okay, and so if I write that down here, what I do to the top when we're talking about equivalent fractions, I also must do to the bottom. So I also multiply by 7 here. That leaves us with S, or in other words, the number of seconds it would take for Maggie to read 63 words would be the result of the product of 4 times 7, which is 28. And so here it would take Maggie 28 seconds to read 63 words. All right? So we're still using the same approach as yesterday. Let's jump to the last 2 questions. Let me maybe scroll down here. Give you guys a second to read through this. Maybe set up the proportion first. Let me refresh the comments so I can see what you guys are saying here. Make sure you're all on board. All right, let me read it out then. John needs 26 cups of water to fill 90 water balloons. Exactly how many cups of water does John need to fill 135 water balloons? All right. Perfect. You guys got a lot of you got the 28 seconds I'm seeing here. Very nice. Yeah, great. Happy to see that you guys are getting that. You guys can always check your answer by comparing 63 over 28. Does it reduce to 9 over 4? You might be comfortable with decimals, and we talked about this yesterday. Try to stick with fractions. They're way more accurate than decimals, but that is a way to check it as well, is to maybe convert both into decimals and double check that they're equivalent. Because going back to our definition about proportions yesterday, we were talking about 2 equivalent ratios, or in our case, fractions, just the way that we're representing them. Glad to see you're getting a hang of it. Yeah, with more practice, you'll start to understand it. Which is why we practice, practice, practice in math. So let me start off number 17 here. 26 cups of water. Okay, great. I don't want to write too much here, so I'm just going to have 26 cups is in my numerator. And that fills up 90 water balloons. Okay, and that is going to be equal to the next relationship, which has to be equivalent. And all that I know is that I have 135 balloons I want to fill, and I'm looking for how many cups would be needed. Okay, so what I would want to do here, and I'm not going to do the work here because we want to jump to our next technique in just a second, I could again reduce it to some point where my 2 knowns, which are my 2 denominators here, have a very apparent relationship to me, and I know what I have to multiply this guy by to get to this one. And what I do to the bottom, I do to the top. And I'll give you the answer here if you want to check what you did last night maybe. C, or the number of cups needed to fill 135 water balloons, should be 39. And just completing that worksheet from yesterday, we can do number 18, which is here. We're talking about Casey. If it takes Casey 45 minutes to run 6 kilometers, exactly how many minutes will it take her to run 18 kilometers? And so setting up that proportion, once again, being consistent with our units, we will have 45 in the numerator of our first fraction. That gives her 6 kilometers. Then how many minutes? Let's have our variable be m. You could also have t for time, whatever you're comfortable with. And then 18 kilometers. Here I don't need to actually reduce my 45/6. Why? I can see a very clear relationship between 6 and 18, and that is that I multiply by 3 to get to the first one to the second, from the first one to the second one. What I do to the bottom, I must do to the top. So I'm going to multiply by 3 here, and that leaves me with m is equal to 135. So if I were to write out a full sentence to answer this word problem, I'm not going to do it on my whiteboard for the sake of time, but I would say, well, it would take Casey exactly 135 minutes to run 18 kilometers. And if you want to be extra creative, you could convert that into how many hours it would take her and the resulting or the remaining minutes from there. But that is what we discussed yesterday. That was one way to solve proportions. And the second way, which I briefly mentioned in the beginning of this lesson, was using something called cross products. And from the little bit that I read in the comments, I don't think I saw too many people answering that unless I missed it, and I apologize for that. But we're going to look at more problems, more proportions to solve. Let me just go to my full screen here for my whiteboard. And before we jump to some of these, what does the cross product, why is that useful as a technique when we're trying to solve, or I shouldn't even say trying, when we are solving proportions? And we'll need some prerequisite knowledge here too, which I'll get to in just a second. But why does this work? Well, when we have two ratios or two fractions, when we're setting them to be equivalent, which is what we're doing when we're solving proportions, that's nothing new, that's all from yesterday, their cross products are also the same. They're also equal to one another. So let's prove that. And I shouldn't say prove, we're not necessarily going to prove that, but we'll show examples where we can kind of guarantee that, you know what, this is true. And I can use that information to solve more proportions where equivalent fractions just doesn't work too well. So let's see here. 6/8 is equal to 3/4. Hopefully you guys agree with that statement there. Why? Because we're looking at two equivalent fractions here. 6 divided by 2 gives me 3. 8 divided by 2, that same operation that I performed with the same number, gives me 4. So these are two equivalent fractions. So we know by definition they are equal to one another. And what you can observe, which is where we're getting the cross product from, quite literally, their cross product, which represents for us the operation multiplication. And let me do this here. Let's use another color for some of our visual learners out there. Are actually the same. Here I get 6 times 4, which is 24. 3 times 8 is 24. So they're actually the same. And I could show you a lot more equivalent fractions on my whiteboard, prove to you that their cross products are the same. I'll leave that with you to try out and see that with any two equivalent fractions that you come up with, that their cross products are the same. For now, you can take my word for it. It is true. And so we can use that information to solve for any unknowns when, again, the first technique doesn't work out for us. Or if this becomes your favorite, you could always use it. It's just that sometimes this might take longer. And so it's really up to you, preference and time, right? And I joked about this yesterday, but it is quite a true fact that mathematicians will always try to go for the fastest, will take the shortest route possible to get to their answer, right? So that is a fact that we're going to use right today to solve some more proportions. And I'll give you an example here. So of course, those were two fractions where they were equivalent. We knew their numerators and their denominators. But let's say I am solving for, and I just have an example here. I have 3/7 is equal to 9, or the denominator, so a fraction where we have a numerator of 9 and a denominator of n. I want to solve for this unknown of n. How can I do that? Well, I could use equivalent fractions, so maybe this is a very poor example, or maybe it's a great example, because what would we get if we were to solve it the first way? And then we can double check our answer. Well, 3 times 3 is 9, so n should be 7 times 3. So this is using our one technique. So I would get n is equal to 21. Let me use a red here to solve this another way. So let's say I just repeated that question, and I'll use red here. If I want to solve it using the second way, using cross products, I would have that 3 times n, it's another way of writing it, is equal to 9 times 7. I know that 9 times 7 is equal to 63. And this is where some prerequisite knowledge is necessary. For those of you that are going to use the cross products and are comfortable with solving proportions this way, you do need to make sure you're comfortable solving an equation like this. So for those of you that have never seen anything like this, there is a Schoolhouse lesson that you can turn to for a review. For the time being, really what we're solving for is some number multiplied by 3 is equal to 63. You can confirm that that is in fact 21. Great, so this method worked out just as well. Another way you can do this is divide both sides by 3, because the opposite of multiplication is division. So if I divide out the 3's on this side, I am left with the fact that n is equal to 21. Okay. So this second technique is the one we'll focus on today. We'll run some problems, we'll do some problems together, and then we'll turn to some word problems, much like yesterday. All right, hopefully we're comfortable with that. Like I said, if you're not too comfortable with solving equations this way, there is a Schoolhouse lesson available for you that you can watch later after today's lesson. For now, you can follow along with the cross products. Perfect. So let me turn to the first few questions. Maybe I'll do the same thing as before. I'll leave the first 3. Hopefully you see that now. Yeah. I'll leave the first 3 on the screen and refresh my comments to see if there's any questions I should address before working on these 3. For those of you that are good to go ahead and try out the first 3 questions, share your answers, and we'll do these together in just a few seconds. I'm seeing a lot of you guys got the answer of 21. Love it. Very good. And I love to see you guys telling me that you're getting this now. All right. Perfect. Nice. I'm just catching up on your conversation here. Glad to see a lot of you are understanding. Again, if you're not, it might be the case where it's the solving the equations portion or maybe not watching yesterday's lesson. So if you are finding this challenging or maybe you want more practice, another approach would be to, of course, reach out to your nearest Mathnasium, and they would be more than happy to provide you with more content to solve more proportions. So let's look at number 1 here. Oh, my markers aren't nice to me today. Pull up another one. So we're looking at 4/5 is equal to 3 something. So I have 4/5 is equal to 3, and then there's a denominator of a. And so of course I'm trying to solve for this unknown of a. I don't see that I can use the first technique too clearly, and so I'm going to jump to cross products. And so I'm going to take 4 times a, and that should be equal to whatever 3 times 5 is. So if I rewrite that here, 4a is equal to 3 times 5. I am going to just erase that because I have the ability to do it here and write that in as 15. That was just the product of 3 and 5. And this is where, again, if you're comfortable with solving for these equations, we can divide both sides by 4 to isolate for our variable, our unknown of a. Whoops, not divided by 5, divided by 4. And depending on what your question would ask of you, and here in this PDF, in this document that was shared with you, you can see just at the very top there, I do ask you to reduce your answer. So practice with your knowledge of reducing fractions. And if possible, convert improper fractions to mixed numbers. And that is exactly our case here. We have an improper fraction, and we want to look at what that is as a mixed number. Again, a separate lesson that we won't focus on today, but if I do convert that into a mixed number, well, how many 4s fit into 15? That would be 3. So here my a, if I maybe squeeze that in here, is going to be equal as a mixed number, 3 3/4. And that should be your final answer as a mixed number. All right. I'm going to erase that. A lot more problems to practice through, so don't worry. Hopefully, by just observing the work, you'll get a hang of it if you are still confused. Here, we're looking for something slightly different. We're looking for the numerator in the first fraction, but that's fine. It's not going to change our technique. We can still utilize the cross product. So I still understand that this numerator multiplied by this denominator, so b, and I can write it out this way if you're not comfortable with my other notation, b multiplied by 17 is equal to 4 multiplied by 3. B times 17 is the same as writing 17 times b. Again, if you're not comfortable with that, that's fine. What I want to do here is still isolate for my unknown, which means I'm going to divide out both sides by 17. Once I get that, I actually end up with my value of b, which is going to be 12, that's 4 times 3, over 17, or 12/17, and that is my final answer. I cannot reduce that any further, and it's not an improper fraction. So there we go. Pretty simple what I did. I used the knowledge of cross products, that if two fractions are equivalent, their cross products are equal to one another. So I wrote that out first, and I isolated for my unknown because that is what I'm being asked to solve for, and that's how I got that. So let's say that one more time with number 3. If I'm going too fast for you, you can always pause it and resume the video, pause the video and resume it when you're ready. This video will also be available on our page afterwards. So if I have 6 over L, 6/11, is equal to 10/9. Again, nothing new. Let's look at cross products. 10 times L. Again, I can write it out this way or just 10 beside the L. And if you solve for this here, meaning you find whatever 6 times 9 is, and then you divide by 10, and I can maybe show that here. Let's do then you can probably see from here, I am left, first of all, with an improper fraction, but I'm also left with an improper fraction I can reduce first. Up to you what you'd like to do. You can reduce it first and then convert it to a mixed number, or convert it to a mixed number and then reduce, whatever works best for you. But I will write the final answer here. Once you do that, it will be L is equal to 5 2/5. Technically, I would have wanted to write this here. I just don't want to run out of space. All right, I'm going to scroll down in the document, show you questions 4, 5, and 6. Again, take a few seconds to try those out on your own. And in the meantime, I'll refresh the comments, see what you guys are up to there. So there you go, 4, 5, and 6. Use the same approach, cross products. Beautiful. A lot of you are showing me the correct answer for the previous problems. In school, I learned this and I did not understand, and now I do. Oh, what an excellent comment. Thank you for sharing that. Sometimes what it does take is just seeing it multiple times, right? And that's not anything new. I mean, I as a student had to do the same thing. There are some concepts I grasped right away and others that I had to revisit a few times, and there's no problem with that. All right, let's look at number 4 here. Let's use our cross product approach right away. I could first try to see if I can reduce fractions and look at equivalent fractions. I'm not seeing anything too apparent for myself, so I'm just going to jump to cross products. Maybe rather than rewriting it, I'm just going to write down my cross product, meaning I will write down 9 times 11 is supposed to be equal to 8 times h. 9 times 11, I'd find that product to be 99. And I would divide out both sides by 8 to isolate for my unknown. And that would leave me with h, which I'll pull up here. Once you do that, you can simplify, and that would, sorry, not simplify or reduce. This is an improper fraction, so you'd want to convert that into a mixed number because of what's being asked of you in the document. This is still a correct answer. We just want to practice with our improper fractions. So here, if you did that, you would get 12 3/8. All right. Perfect. Let's look at number 5. I'm going to erase that. We have 8 with the denominator of n is equal to 2/5. I do see actually a relationship between the two numerators, so I could use my technique from yesterday. So you could do that, and if you did that, great, that's fine. For the purpose of just today's part 2 lesson, I will practice with my cross product, so that's what I'll do for number 5. But again, I do see another technique I could use. I'm going to jump to 8 times 5, that is 40, and I'm going to jump to n times 2, or 2 times n, that is 2n. This one's pretty nice. I can divide both sides by 2 and get a nice whole number of 20. Really nice one. And maybe I can squeeze in number 6 here, and then maybe we'll work through some word problems after this. So again, let me just write out the cross products that are going to be equal to one another here. 7 times 2 is 14, and 19 times a is just that, 19a. So I want to divide both sides by 19 to isolate for that unknown of a, and it looks like that's all that I can do here. So I'm just left with a is equal to 14/19. So hopefully, just like I mentioned yesterday, to solve proportions, we really look at 2 techniques. And I want you to be able to see that no matter where my unknown is located, whether it's in the numerator of my second fraction, the numerator of my first fraction, the denominator of my first fraction, or the denominator of my second fraction, it doesn't change what I'm going to do. It might change where the variable shows up when I rewrite my cross products and have my linear equation. But that doesn't change still your approach to how you're going to solve it. So I don't want you to see these problems as different. They're all the same. Okay, you're still using the same approach. So rather than finishing off 7 through 12 on this page, I'll allow you guys to finish that on your own. I always say this, but I welcome you to reach out to nearest Mathnasium for assistance on these extra problems if you find you need it. Let's jump to maybe 2 word problems before we end off our series on solving proportions. So you can see question number 17 here. If Morgan can read 7 books in 8 days, which is extremely impressive, exactly how many days would it take her to read 20 books? How could we do this? So we started off with word problems today as a review of what we did yesterday. So hopefully you have that same approach for these word problems. So far nothing is different. We're still going to approach the setup the same way, just being mindful of the consistency of where we're placing those units. So we have 7 books is being read in 8 days. And using that same structure, meaning books in the numerator and days in the denominator, I'm looking for how many days, so that's my unknown. And I'm looking at 20 books. I don't want to have a question mark. I kind of just put that there as a placeholder for knowing that that's where my unknown is going to be. Now I can bring in a variable, and it's looking for days, so why not? I'll just include D as my variable. If I don't like, if you guys aren't comfortable having all this extra English here, all these extra words here, you can remove it and rewrite your proportion that you are solving. 7/8 is equal to 20 over D. not a very clear relationship between the two knowns, which is the 7 and the 20, the two numerators. So let's jump to cross products. And I don't want to confuse you with what I'm doing here. So let me just write 7 times d, again the cross product, is equal to 20 times 8. So you can think of this as 2 tens multiplied by 8, so you get 160. And then you're going to solve for d, which would mean dividing out both sides by 7. And I'm not able to do that on my whiteboard here, so I'll just give you that answer. You're going to get an improper fraction, so change that up into a mixed number, 22 and 6/7. Again, that's a different lesson for a different day, which you guys can pull up in our library of Schoolhouse lessons or reach out for some assistance from your nearest Mathnasium. Right? So it's going to take her a little over or almost 23 days to read those 20 books, which is still extremely impressive. Let's maybe do one more problem and then we'll be done for today. I'm going to pull up question number 14 here and give you guys a few seconds to try that out. Again, let me refresh the comments here. Good, awesome. Refresh them, and I'm seeing the right answer. Very nice. Yeah, this trick is really quick, helpful, and easy. That's right, yeah. Right, and sometimes, like I said, we'll jump to equivalent fractions, reducing fractions, because, believe it or not, that will be the fastest way. And it, at the very least, is a great way to begin the conversation of solving proportions, because it really makes sense why the two have to be equal to one another, and why, when we find the value of that unknown, it really does make sense. So number 14 here asks of us, if it takes 5 pounds of peanuts to make 9 jars of peanut butter, exactly how many pounds of peanuts is needed to make 24 jars of peanut butter? Great. So I'm just going to set that up for myself. I'm seeing 5 pounds. Just choosing to have that information in the numerator, just because this is the first thing I read. That makes for me 9 jars of peanut butter. That's going to be equal to the next relationship that I need, which is that I want 24 jars of peanut butter, and I just don't know quite yet how many peanuts that will require of me. I don't know how many peanuts to go buy at the store to make this many jars. So I'm going to include here a variable, and let's just have P for pounds or P for peanuts. And so I'm going to jump to my cross product. I don't have to rewrite it as just 5/9 is equal to P over 24. I could just jump to the cross product. Okay, really depends how comfortable you are, but then I would get 5 times 24 is equal to P times 9, 9 times P, or 9P. And we would divide both sides by 9. And when you did that, if you did that already, you should get, I'm writing it in red here, but once you divide out both sides by 9, you'll get an improper fraction. So converting that into a mixed number, if Sandra did her math correctly, you should get 13 1/3. Right? So here you'd be left with 120. Divide that by 9. You could reduce first, like I said earlier, and then convert to mixed number, or do the opposite. Either way, you should end up with this answer. And if you try out the remaining word problems on this page, I guarantee you you're using the exact same technique. Set up your proportion, change it maybe into a proportion without any other words, just the numerical values of each. Make sure you've been consistent with your units. That's just something we're always careful of no matter what we're setting up. And then use your cross product technique to solve for that unknown and just make sure that your final answer is a mixed number rather than an improper fraction. All right. I'm going to end it off there. Again, there's more practice available to you if you find that you are confused, or if you want to actually check up on your answers. The best way for you to do that is to reach out to the nearest Mathnasium to you and see what else you can learn with us. We'll create an individualized learning plan for you, so it'll be very much specific to your needs, your desires, what it is that you want to learn in math, versus what we're doing here, which is really just sticking with one topic and just doing a lot of problems all at once. Okay? We will see you all again tomorrow. We will have another Schoolhouse instructor teaching you another lesson tomorrow. I hope you tune in. I hope you have a wonderful day before that. And we'll see you again. Bye-bye, everybody.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.